Hi, and welcome to the next section of this course, Keras Installation and API. In this section, we will start with installing and configuring Keras, then learn Keras API, and finally look at the callbacks for customizing the training process. Now let's move on to the video, installing and configuring Keras. In this video, we will show how to install Keras, then we will configure Keras and finally install Keras on Docker. We will start with installing Keras. First, we need to install some useful dependencies. Install the NumPy package, which provides support for large multi-dimensional arrays and matrices, as well as high-level mathematical functions. Then, we install SciPy, a library used for scientific computation. After that, it might be appropriate to install scikit-learn, a package considered the Python Swiss Army knife for machine learning. In this case, we will use it for data exploration. Optionally, it could be useful to install Pillow, a library useful for image processing, and h5py, a library useful for data serialization, used by Keras for model saving. A single command line is enough for installing what is needed. Pressing the Enter button will start the installation and collection of these dependencies, as you can see on your screen. The installation may take some time. Please sit back and have a sip of coffee until the installation process is completed. So the installation process is now complete. Alternatively, one can install Anaconda Python, which will automatically install NumPy, SciPy, scikit-learn, h5py, Pillow, and a lot of other libraries that are needed for scientific computing. You can find the packages available in Anaconda Python at this webpage. In the screen, you can see how to install the packages for our work. Now we will move ahead and install Theano. We can use pip to install Theano, so type in the pip, install, and Theano. So Theano will start to download, and then it will get installed in our Ubuntu system. This may take some time. Cool, Theano is successfully installed, as you can see on the screen. Next we will install Tensorflow. After the installation of Theano, we can install Tensorflow using the instructions found on the Tensorflow website. Again, we simply use pip for installing the correct package, as shown in this link. Here you can take a look at a guide on how to install a version of Tensorflow that enables you to adapt applications in Python. You can also have a look at Mac OS, Windows, and from other sources. We can simply use pip command to install Tensorflow. For that, type in pip, install, and Tensorflow. So Tensorflow is already installed in our system. If you have not installed it, then it may take a little while. We can also use pip to install the correct package. For instance, if we need to use GPUs, it is important to pick the appropriate package. We will just reset our screen. Post that, we will install Keras. Now we can simply install Keras and start testing the installed environment. Pretty simple. Let's use pip again and install Keras. So we have successfully installed Keras. Now after installing, we will be testing Theano, Tensorflow, and Keras. We will test complete environment. First, let's look at how to define the sigmoid function in Theano. It is very simple. We just write the mathematical formula and compute the function element-wise on a matrix. Just run the Python shell. Then type the code. The code starts with importing Theano, and type in the rest as shown on your screen. As you can see on the screen, we have imported Theano and added in a few lines of code, which defines logistic equals Theano.function. So run the code and you will get the output as shown highlighted. So Theano works. Let's test Tensorflow. For that, first run the Python shell. Now we can test the TensorFlow by simply importing the mnist dataset. For that, we will add the tensorflow.examples.tutorials.mnist to import the input data. We can ignore the warning. Then we will add the next line, that is mnist equals input data dot read data sets mnist data, and specify one hot value as true. Run it and you will get the output successfully. You will get the messages like successfully downloaded train images, extracting mnist data train images, successfully downloaded train labels, and so on. So you will receive the output similar to one shown on the screen. Now we will move on to configuring Keras. Keras has a very minimalist configuration file. Let's load it with a VI session. For that, first we will navigate to .keras folder, where we have the Keras configuration file. To load it with a VI session, we will type VI followed by name of the configuration file, that is keras.json in our case. The parameters are very simple. The highlighted lines are the default parameters in our machine. Let's take a closer look at these parameters. Float x can be either float 32 or float 64. Here it is float 32. Epsilon, the epsilon value used during computation. Backend, can be either Tensorflow or Theano. We have used Tensorflow. And image data format. Now it's time to exit from the configuration file. Next, we will be installing Keras on Docker. One of the easiest ways to get started with TensorFlow and Keras is running in a Docker container. A convenient solution is to use a predefined Docker image for deep learning created by the community that contains all the popular DL frameworks. Refer to the GitHub repository at this link for the code files. Assuming that you already have Docker up and running, installing it is pretty simple, which we will see now. First we will type git clone and specify the link for cloning into DL Docker. This screen says something like, after getting the image from Git, we build the Docker image. So first we will navigate to DL Docker folder. After getting the image from Git, we will build the Docker image by typing docker build command. Specify DL Docker here and type in cpu-f dockerfile.cpu, since we are building it for CPU. Don't forget to enter the ending dot or else you will get error in the output. You will start getting the output on the screen. The output consists of 34 steps. These may consume an entire hour of yours. Meanwhile, you can watch your favourite series on Netflix till you get output. Clear the screen. Next we will see how to run it. Use docker run command -it-p 4x8:4x8 -6066:6066 Floyd hub dl docker :cpu, since we are using the CPU version, and then we specify bash at the end. This process may take some time. So in the output we get the status as downloaded newer image from Floyd hub dl docker :cpu. Clear the screen and type in ls to see the content. So we have Cafe, iTorch, Jupyter, .sh and Torch. From within the container, it is possible to activate support for Jupyter notebooks. Next we will type in sh run jupyter.sh to run the Jupyter shell. So the server has started and the Jupyter notebook is running. So Jupyter notebook is running at localhost 8888, and we can access it directly from the host machine on port, as you can see here. And it is also possible to access the Tensor board. For more information you can refer to this website. So here we have come to the end of this video.